Welcome. As a continuation to the previous video, in this video also we are going to discuss binomial distribution. Okay. Be it any distribution, once you study some new distribution, try to derive MGF, mean and variance by yourself. Okay. Here, it is simply said that MGF of binomial distribution is this and mean is this and variance is this. Actually, we are asked to prove it. Okay. Let me give you the idea about how to derive these things. Okay, so we know that the density mass function is ncx p to the power x q to the power n minus x, and x is varying from 0 to n, isn't it? Right. Now, what is moment generating function? It is expectation of e to the power tx. So that is summation, okay, under all x. Here x is varying from 0 to n. Okay, e to the power tx ncx p to the power x q to the power n minus x. And now what you can do is that, okay, this ncx, let it be here, this p to the power x e to the power t whole power x, we can write this in that fashion as well. So p e to the power t whole power x and q to the power n minus x. And if you recall from the standard binomial expansion, that is a plus b whole power n is simply summation x runs from 0 to n ncx a to the power x b to the power n minus x. Okay, if we make use of this one, what we get is this is p e to the power t plus q whole power n. So this is our binomial distribution, mgf of binomial distribution. Now we need to derive the mean. So let us find the derivatives of this one. The first derivative is n times of p e power t plus q to the power n minus 1 product with p e to the power t. Okay, and the second derivative is, here np is a constant, so we take them outside. Now it is in the product form. So let me differentiate, let me keep the first quantity as it is, and derivative of e power t is e power t itself, and let me keep this e power t as it is and differentiate this one. So this becomes n minus 1 p e to the power t plus q to the power n minus 2, and again when I differentiate this quantity I get p e to the power t. Okay, now let me calculate the derivatives at the point 0. Okay, here it becomes n p e to the power 0 is 1 plus q n minus 1 p, it is again 1. Okay, what is p plus q? It is 1. So 1 to the power anything is 1, so we end up in np. Okay, this is our mean. Okay, now what is m double prime at 0? If you see, it is np, and again it is 1, so p plus q is 1, 1 to the power anything is 1, and this quantity e to the power 0 is 1, so we get 1 plus here it is 1 n minus 1 times of, it is again 1, and we have p here. Okay, if you notice, so it is np 1 plus np minus p. Okay, this 1 minus p we shall write it as q, so it is np plus q. Okay, and variance of x, that is sigma square, which is nothing but e x square minus mu square. Here what we have found is e to the power x square, so it is n square p square plus npq minus np whole square. These two gets cancelled and we are left with npq. That is our variance. Okay, and if you look at the next problem, it is given that x is some binomial random variable with mean np and variance 3. We are asked to find out probability of x equals 0. Mean is what? np, that is given to be 4, and variance is npq, and that is given to be 3. So from this, what can you do? So npq upon np is 3 upon 4, which gives us that q is 3 by 4, Therefore P is 1 by 4, and we know that probability of x equals x is ncx p to the power x q to the power n minus x. So we need probability of x equals 0, which is nothing but nc0. P is 1 upon 4 to the power 0, 3 upon 4. Here what? Okay, now we need to find out n as well, right? So we know that P is 1 upon 4. So therefore NP equals 4 implies N equals 4 by P. So P is 1 by 4, therefore it is 16. So N here is 16, isn't it? So 16. So basically 16C0 is what? It is 1 itself. So we need to find out 3 upon 4 to the power 16, right? Now moving further, again we have some problem here related to binomial distribution. N is given to be 6 and probability of x equals 4 is same as that of probability of x equals 2. And we are asked to find out the probability involved in it. That is the p value we need to find out. We know that the mass function is this. We just equate it. We apply the value in the mass function, so we get something of this form. So p to the power 4 1 minus p square is same as that of this quantity. When you find the values and simplify, you get p to be equal to 1 upon 2, right? Okay, moving further, we have another problem. Yeah, this is the same problem that we have done. So we are obtaining the binomial distribution of this form. Next, whenever you need to calculate some probability like this, x greater than or equal to 2. So you can do this as 1 minus p x less than 2. So here it is starting from 0 only. So 0 and 1, only those two probabilities you will have to calculate and subtract that from 1. Okay, 1, 2, 3, which means 1, 2 and 3. Only those three probabilities you will have to calculate and add them up. Probability of x less than or equals 1. So including 1. It is starting from 0. So 0 and 1 only you will have to calculate. If you see in this problem, 6 dice are thrown 729 times. How many times do you expect at least 3 dice? So a 5 or 6. Okay, this is some tricky problem, but not that tricky. Okay, here 6 dice. So it means you have some number 6. 729 times. Okay, you have another number. Okay, how many times do you expect at least 3 dice to show 5 or 6? So uh, so here what we can consider is that obtaining 5 or 6 in a dice is a success. Okay, here throwing a die is an experiment, is a Bernoulli trial. Here to get a success you should have 5 or 6. So the probability is 2 upon 6. If we get 5 or 6, we are getting it as success. So it is 1 upon 3. And of course, it is telling us that Q is 2 upon 3. Okay. Here, 6 dice 729 times. Okay. First of all, let us slow step by step. 6 dice. When we throw 6 die, we expect at least 3 dice to show 5 or 6. So the probability of obtaining at least 3 means probability of x greater than or equals 3. Okay, out of 6. So it is probability of x equals 3 plus probability of x equals 4 plus probability of x equals 5 plus probability of x equals 6. We'll have to calculate all these things, or 1 minus probability of x less than 3. So when it is less than 3, 1 minus probability of x equals 0. There is a chance that no die is showing it. Probability of x equals 1 plus probability of x equals 2. Okay. Comparatively, here we need to calculate 4 different probabilities. Here we need to calculate only 3 different probabilities. Okay. So it is better to go with this. But it is completely up to individual to select which is to be used. Okay, here I have used the second one. So I have calculated the probability when no success is obtained, 1 success and 2 success. We just calculate it and simplify it. Okay, now that we have thrown 6 dice for one time, okay, we are expecting it. for 729 times. So you just need to multiply it with 729. That's it. Okay, suppose instead of 729, if you are asked to do this for 1,000 number of times, you just have to multiply 1,000 with this probability that we have obtained. When we throw 6 dice at once, what is the probability of success? Okay, you just find it out, then multiply that with the corresponding number of times. That's it. Thank you.